Relational operators are related to expressions between the left and right hand side. These are also operators that produce value. Okay? Exactly same in the previous operator. That is a math. There's a numerical. They do the numerical operation, and this one is a relation operation. Okay. But output of this operation is the logical value, because it only tells you true or false. Okay. That's why it is also called the Boolean expression or the logical expression. Okay. So this also we are familiar with greater than and less than, greater than or equal. But this one is the equality. Okay. This is not equality. This is just a symbol for assignment statement. This is equality. Okay. This equality, this relational operator is to check that the value on the left hand side and right hand side are the same or not. Okay. Okay, let's see the example. What is this one? True, right? That's why if you see the workspace, you can see the one assigned to this variable, but this type is not the double. Type is the logical. Basically here, these types of this variable or values are the logical. Okay. This one false, right? That's why 0. This one, what is this one? False, right? So 0. Okay, but here, don't confuse this part. Okay, so basically the order of the operation is you finish the expression part and then assign the value from the expression to the variable. Okay, that's why this is not something like a 3 assigned to the RO3. Okay, basically you finish the expression part first and then assign this value to the RO3. Okay, don't confuse this operation. Okay, what about this one? Oh, I forgot to mention that this one, this is called to check that it's not equal. Okay, 3 is not equal to 7, that's why it's true, right? 3 is less than or equal to 3, that's why it's true. Okay, makes sense? Okay, good. Okay, the logical operators are the operation between the logical value. Okay. There are or, and not, and there's one more XOR, but I will not cover this in this lecture. Okay. These 3 operators are commutative. For instance, this one is the same with this one. Okay, let's see the one by one. OR operator, or is the expression is the true if at least one true exists in either X or Y. Otherwise, a false. Let's see this column. This is the OR operator. If x is a true, y is a true, true, because there's at least a one true. True, false, also true, because there's a true here. But if you're false and false, these are false, because there's no true. Easy, right? What about and? This is and operator. X is a true and y is a true. And this operator is a true only if both are the true. Okay? True, true, true. Otherwise, the true, false, there's a false here, there's a false. False, false, false. Okay? You understand this operation? Now this is just to give you the opposite answer. X is a false. X is a true, that false. True, false, false become a true. Okay? So X, this logical operator is a commutative, and then this value is the same with false and true. Make sense? Okay, let's see example. This is n, and true and false are constant that indicate the logical 1 and logical 0, right? An operator, true and false, become a false because there's a false here, right? This is a 0. I mean, again, this is a type all logical. Okay? This is or 1 or 0, 1, because at least a 1 here. This is 0, right? There's no 1 here. Okay? True and true, that is a true, right? Because all true. 0 and not false. Now false is the true. 0 or true, that is a true. Not false, so true and true, that is a true. Not true, false, or false, there's no true, that's why 0. Okay, does it make sense? Okay. You might think of the what we learned is a simple operation or operator, but this is extremely useful in MATLAB programming. You'll see the value. Okay, this is a challenging topic. Okay, very challenging. There is also operator precedence between the relational, logical, and numeric operator. I'll keep telling you, these all operator, okay? Okay. The reason why we are easily understand the numerical operator is that that's similar to the mathematical operator, but again, these are all operator. Okay. So here, this is the precedence from the highest and lowest. So this parenthesis is the highest precedence, and then this logical operator is the low precedence. Okay, let's see the example. Okay, 3. The parenthesis is highest operator precedence, so this will become a 4. And this do the operation of this one, that's why true. Okay, but here this is a logical, this is a double. Okay, what about this one? Parenthesis of first, that is the false, right? False or logical 0. So logical 0 plus 3 is Logical 0 is to the typecasted to the double 0. That's why this becomes a 3. The outcome is a 3 and double type. Okay, what about this one? Okay, plus is the higher precedence than the relational operator. That's why this one, 1 plus 3, is the conducted first than this one. That's why this is the same with that one. This is true. Okay. Value 1 and value 3 are same expression, but I'm not recommending, the writing this one because it's a confusing, right? So that's why I always recommend use the parentheses like this. Okay. But remember that in here, let's take a look at this one. All this one is very strange, right? Because this is not a math equation. This is the valid programming script. Okay? Program script is run based on the rule inside. The rule is that these are all the operator. Okay? And then computing the value based on the operator precedence. Okay? That's why there's no error on this expression. Okay? So do the plus first and then do the apply relational operator later. Okay? That's why you will get this value. Okay? Okay, let's think about what values are assigned to each variable. Okay, what about this one? This is the 3 less than 4. So true, right? That is a logical 1. Logical 1 is a less than 4. So relational operator here. Relational operator is producing the logical value, but this is the relation between the numeric value. Okay? What it means is, in this case, this one is implicitly converting to the 1 double. Okay? That's why this one performed 1 less than 4. That's the true. What about this one? There's a parenthesis as 4 less than 5. That is the true. So they implicitly converting to the double 1. 3 is a less than 1. That's why false. Make sense? Okay. What about this one? 10 less than 4. 10 is a larger than 4. That's a true. And 4 is a larger than 1. True. That's why 1. Okay? That's obvious, right? You can perform the logical 5 and logical 6 variable, LG5, LG6 variable the similar way. What about this one? 3 first plus is a higher precedence. That's why 7, 2 less than 7. That's true. Okay. Again, regardless of the operator precedence, it is recommended that you try to use the parentheses to clarify the operation order, because the parenthesis is the highest precedence. Okay? Okay, how to write a code to check if x lies between the 5 and 10. If yes, 1. Assigned to 1, here's the logical 1. Logical 1, logical 0. that is a true, that is a false. Okay? If you hear this these questions, I think you're tempted to write a script like this one, right? Like this, right? Like this. Okay? However, this is the completely wrong. Okay? Do not make this explained. Okay? Why? Let's see the example one by one. Okay? x1 is a 6. Let's evaluate x1 is lies in between the 5 and 10. Okay? This is the correct approach. Okay? x1 is larger than 5 and x1 is less than 10. Okay? That is this one, right? Make sense? So what about this one? What happened? There's no, it's the same operator. So you do the operation from the left to the right. Okay? So you do this one first. What is this one? 5 is less than 6. That is the true logical 1 less than 10. That is, this is implicit converting to the 1 less than 10. That's true. Okay? This is the same thing, right? Because it's operation from the left to the right. So this is the true. Okay? Do you think that this script is correct? Answer is correct, right? But it doesn't mean that this script is correct. Okay, let's see this example. x2 is 11. That produce x2 is larger than 5. That's true. x2 is less than 10. That's a false, right? That's a true and false. That is the false. That's the correct answer, right? What about this one? 5 is x2 is 11. 5 is less than 11. That's a true. True less than 10. This is a logical one. That's also true. Both are true. Okay. Okay, basically, this script, regardless of the x value, this gives us always true. Okay? That's why this script is wrong. It's totally wrong. Okay? This is not evaluating this question, this condition 5 and 10, because this one is always produces a true or false, and then this always less than 10. Okay? The point is, this script is wrong, so do not make this script. Okay? There are many built-in functions in MATLAB. Okay? And also, you can make your own function. To use the function, you call the function with a input argument. And then pass this input argument to the function and then return the output. Okay? For instance, absolute value function, if you're putting in the -4 in this absolute function, that return the 4. Okay, that is the output. Okay, I will cover the useful the built-in function in the later module, but this is how we use this function in MATLAB. Okay. Okay, let's learn about some basic math function. This is a rounding function. Rounding function is to map the real number to the integer number. There are 4 different ways to do it. Round is the map to the number to the nearest integer, and map the number nearest integer toward the 0. Okay, like this. And then floor is the negative infinity. Okay. Cell is the positive infinity. Okay. So every time you use this rounding function, you refer this drawing. This is useful. Okay. Let's see how it goes. Okay. 0.3 is a place here. So round 0.3 is the nearest integer is 1, right? Oh no, 0, right? Nearest integer. Fix is the toward the 0. That's why it's a 0, right? Toward the 0. Floor is the negative infinity. That's why it's a 0 as well. Cell is the positive infinity. That's why 1. Okay. Let's take a look at the minus 0.6. This one. Round is the nearest integer is the minus 1, right? Fix is the 0, right? Toward the 0. That's why it's a 0. Okay. And the floor is the negative infinity, this direction. That's why it's minus 1. And cell is a positive direction. That's why it's 0. Make sense? Okay, here's another example. Let's take a look at this example. But I will only cover this part. Okay, x1 is 10.3. Okay, so cell is the nearest integer in the positive direction, right? That's a positive infinity. That's why x1 cell become 11. Fix is toward the 0, right? That's why 10. Floor is the negative infinity. That's why 10 as well. Okay. So you can check this other value as well. Okay. By the way, you don't have to memorize this function and their usage. Okay. Please type the DOC as a command window. If you want to use see how to use this function, you can type the DOC and the function name here. Okay. For instance, let's say here's the MATLAB window. If you want to see how to use the round function, DOC round in the command window, you will see the syntax and then description, and then you can see the example as well. Okay. So another math functions are computing the absolute values of the x, ABS, square root of the x, that is SQRT, and then sign, give you the signs of your variable. The negative value, that gives you -1, 0, 0, positive, and just 1. Okay? And the RAM function is to compute the remainder of the x divided by the y. this ramp function is to take the two input x and y. For instance, ram 25, 4, that is the remainder is the 1, right? In this case is 0, this case is 4. Okay, that's obvious, right? This is an example of how to use this common math function. We create the xyz variable, abs, absolute value of the x, sign of the x, that is the 4, that is the -1, right? Okay. What about the xzr, that is x minus 4, z is 2, remainder is become 0. What about the remainder y, z, y is 9, z is 2, remainder is 1, right? Okay. As I mentioned in the course syllabus, I recommend type all this script to MATLAB, okay? MATLAB. And then check this workspace so that you get the same result, okay? Okay, these are the function versions of the logical operator, okay? Basically, these are the exactly same with this one, okay? Here's the example. x1 is the true, x2 is a false. If you do this operation, you can get the false, right? Because x2 is a false. The same operation is like this, x1 and x2. Okay? So why do we use this function, by the way? If you take a look at this, if you compare these two scripts, that's the same operation, but this is much more readable, right? And clear, right? Rather than this. Okay? So in some cases, not every cases, I recommend to use this built-in function because it's much more readable, okay? And then reduce the risk of the error. Okay, so I would like to explain the random number. It'll be used in all your MATLAB grader problem. MATLAB can generate the random number. Okay, actually it's not a true random number. It's actually a pseudo number because MATLAB just read the random value from the table. Okay, in each table there are lots of the number. I'll say it's a randomly generated. Okay, it's not randomly generated. It's a random number. I'll say. Okay, whenever you generate a random number, the seed, that is a table ID. Table ID is assigned based on the clock. Okay, the time when you run script. Okay, and then read the value on the table in order. Okay, that's why whenever you're running your software, you're running your tool, the clock is different, time is different. This means that they read a different random number table and then read this value. That's why it looks like the MATLAB generate a random number, okay? Although it's a pseudo random number. Okay, so there are built-in functions to generate the random number. Ran n is to generate the n by n random real number matrix where each number is in interval is a 1, 0 to 1. Okay, so when you put the 1 here, so it's basically it's a 1 by 1 matrix, a random number. 1 generate the 1 random number. Okay, you run this script again you generate another random number. Okay? Because this number and this numbers are different. Why? Because your execution times are different. They're reading the random number in the different table. Okay, so that's why if you see here, RNG is the specified seed for random number generator. Okay, what it means is, oh, I'm going to read a random number value in the 10th table. Okay, so that's why if you run this, you'll get this value, and then run this again, you'll get the same value because you're reading the same value. Make sense? Okay, so rand is basically generate a random real number. So the most frequently used function is rand I, that is create the random integer, okay, in the specified range. So you first put the range here, and then it's generate n by n matrix. Okay, so we're going to learn about the matrix and the array variable in the following lecture. Okay. Let's assume that you're going to compute the value of the y when x is equal to 10. You might write the script like this. Okay. You will use the many parentheses, can avoid the potential mistake in the operator precedence, right? Like this. However, the better approach is to separate the denominator and numerator. So by introducing two variables, it's like this. Okay, you introduce a y denominator, nominator, and the y denominator, and separate these two. And then you write another line that the division between them. Okay. Let's compare this one and this one. So which one is better? I'll say the second one is a much more readable and clear, right? Rather than this. Okay. So if you write a readable and then clean code, you can avoid a mistake or error, which are very crucial in programming. Okay. I'm not always break this code into the two or multiple line like this, but in some cases, this is a better script, to compute this value while avoiding the mistake. Okay. Okay, before closing the module 1, I'd like to talk about the fundamental questions of why we are using the programming tool. Okay, suppose that you are solving the very simple problems like f is equal to m times a. Okay, if you are using the MATLAB as a calculator, so you'll write the code like this. Because you know the mass and then acceleration, and then you know the unit conversion from the inch to the meter, you write the script like this if you're using the MATLAB as a calculator. However, if you're using the MATLAB as a programming tool, I'll recommend writing the code like this. Okay. You define the three variable, numeric variable, and then assign this value. Okay, with this comment symbol, you can put the comment that refers to what it means, and the unit, their unit, kilogram, inch for the second square, and then this is the inch to meter unit conversion, right? Or you can just put a comment like a unit conversion inch to meter. Okay. If you make this comment, you can readily know what this means, right? With this, when you read this script, right? But in here, sometimes you're lost, right? What it is. But with this commenting function, you can understand what you're doing here, right? And then you compute the force like this. Mass times acceleration and inch to meter. Okay? And then you can put the equation like this. Okay? Okay? What do you think? This second code is much more readable, right? And also allow the others to understand your code. If you give this code to the other, they don't understand, right? But if you show this script to the other, they can understand what you did. At some point you make mistake, let's say inch, meter to inch. Maybe if you use the meter to inch here, you can easily find the error, okay? Or other people easily find your error, okay? That's it. This is all for the module 1. And please solve the tutorial problem in MATLAB Grader. And then watch the video or look at the solution as a model solution to check your answer. Okay? Thank you, and then see you next lecture. Bye.